Alrighty, we've gotten to a practice test again. This is some exciting stuff. We're done with unit. I almost said two. Trace. Alright, guys. I've been drinking some coffee, try to stay awake. It's an hour. It's going to be a long one. I'm not even going to lie. It's 9 pages. You don't have to do it all in one sitting. I probably won't either. Maybe I will. I don't know. If I get a little punchy, a little crazy at the end, you'll know I got a little crazy and punchy. Ooh, that's hot. Okay, kids. Let's see if Mr. Key's working today. Maybe not. Oh, we gotta try drawing, maybe? I don't know. Oh, there we go. Mr. Key. Well, it's working for now. Let's see how we can get through this. Okay. What is the equation for the axis of symmetry? You know, on the test, I had a kid write this. X equals negative b over 2a. Well, that's the formula. It's not the equation, you goofballs. Man, crazy. So what we're going to do is we'll do negative b, which is 5, positive 5, all over 2a. 2 times 1. So that's 5 halves. So x equals 5 halves is the axis of symmetry. What are the coordinates of the vertex? Well, I'm not exactly sure, but I know that the y value is 5 halves. So I'll grab my calculator, go to my trusted dusty calculator. We'll take 5 divided by 2 and stow that into x. And then we'll type it in. X squared minus 5 minus 5x. Minus 6. Negative 49 over 4. Negative 49 over 4. Now, if you wanted to know what that was as a decimal, you just do a little math, but it would be negative 12.25. So what is the domain? Well, the domain of all parabolas is negative, unless otherwise stated, is negative infinity to positive infinity. The range, since this is a parabola that's going up, is from this point right here, which will be the lowest point, negative 49 over 4, all the way up to positive infinity. While we're here, we're going to graph it, so you might as well grab this puppy, go over to graphing mode, and we'll get x squared minus 5x minus 6. And there it is. I go to the table. Control T. Let's see. Can I go any further up? So negative 2, 8. Not going to make it. Negative 1, 0. 0, negative 6. Do that one. 1, negative 10. 2, negative 12. Then we got this little piece right here. Then we'll just match them going up. And there it is. Like that. And then let's see if I can actually hit a few of these points. Like that. Boy, that hard. Okay. So what is the Y-intercept is this question. Well, the Y-intercept is clearly just this number at the end. So it's just 0, negative 6. Is the vertex a min or a max? Obviously, it's a min since it's at the bottom. Let's see what other questions we ask. What are the roots? Well, the roots are where it hits the x-axis. So the roots are negative 1 and 6. Is the curve concave up or concave down? It's concave up. See that? Looks like a U. Concave up. Now, the points where it's increasing and decreasing. This seems to be still some contention with you guys about what's going on with this. All the way over here, starting in infinity, it's decreasing, 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 until it gets to here, and then it turns around and it increases, 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 increases. But when we're talking about increasing and decreasing, we're trying to use the x values. So from negative infinity all the way over to here, it's decreasing. And then starting from here over to this direction, it is increasing. So the answers for increasing is from 5 over 2 to infinity. For decreasing, it's from negative infinity to 5 over 2. And notice I did not use 5 over 2 because at that point, it's turning around and going the other direction. So that's why I figured I'd throw a couple of questions in where you had to show a function that was decreasing from negative infinity to negative 3. So as I'm cruising down from negative infinity to negative 3, so what I'll do is find negative 3, 1, 2, 3, and pick any point. And I'll draw a parabola where it is decreasing, decreasing, decreasing. And as soon as I get to x equals negative 3, I increase. I don't care what the y value, it doesn't matter. It's the fact that this here is negative 3. How about decreasing from negative infinity to 4? Well, it's the same kind of a problem. I'll find 4. 1, 2, 3, 4. There's my point. And I can even do it right there. There. It's decreasing from negative infinity to 4. Draw a function whose discriminant is negative. When the discriminant is negative, you have imaginary roots. If they're imaginary, then you can't even see them, which means you have to imagine that there's roots. So I could draw a parabola that looks like this. If I don't like that, I could draw a parabola that looks like this. Just so long as it does not hit the x-axis. That's it. Draw a function that has a discriminant of 0. Discriminant of 0 means it hits the x-axis once. So maybe my parabola looks like this. Maybe my parabola hits once here. Maybe my parabola hits once here. As long as it only hits the x-axis once, it has a discriminant that is equal to 0. Draw a discriminant that is a positive, perfect square. Since it's positive, it's real, and it's a perfect square, means that it's going to hit at 2 nice points. So all I would expect for you to do is to draw something where it hits. It doesn't matter if it's going up or it's coming down, but that it's hitting 2 nice points. When it's not a perfect square and it's positive, it hits 2 points. You really can't tell. Somewhere in the middle here. And, maybe draw a parabola where it doesn't hit at nice points. Draw a function that is concave up. Very simple. Concave up. Concave up. Concave down. That's it, brother and sister. Time for some Brugger's coffee. When I finish problem number 9 and I want to go on to problem number 10, I take my Brugger's coffee out and I have some and I drink it and I enjoy it. Oh man, that hurts my throat because my throat's so sore. Hopefully I can make it through this video. All right, we're going to go into vertex form. And what I want when I'm done is f of x equal to some parentheses squared and some number here. So plus or minus, I don't know if it's plus or minus, but some number over here. I'm going to have x here. I could have a number out front here. And I'm going to have a number here. And this part right here, this thing and this thing is my vertex. That's why it's called vertex form. So it's basically the idea of using completing the square. So we're going to start with x squared plus 12x plus 10 equals 0. And we're going to do completing the square. So I'm going to toss this over to the other side. I get x squared plus 12x. And since it's completing the square, let's toss a couple squares in. Equals negative 10 plus square. Now, what goes in those squares is half of this, plus 6. Well, that's what goes here, x plus 6. And 36 goes here, and 36 goes here. So, equals 26. So, the last thing is just to bring it back. Bring it back, y'all. Bring it back, y'all. Oh, yeah. Ooh, I missed my call-in. Should have been a rapper. Or whatever that was. And then bring that back over, and it becomes negative 26. So this... Oh, and I forgot to put the squared here. I apologize. This is in the form that I was looking for it. So my function is f of x equals x plus 6 squared minus 26. What's my vertex? Well, it's right here. It's this and this. It's, remember when it comes out of the parentheses, it gets a sign change. And when it's outside here, it's just whatever it is. Now, if you ever want to know that you got it right, you could always bust your calculator out. I'd say bust your calculator out because that's what all the cool kids are saying. I bust my calculator out, and I come over here, and I go, what was the original? Control T, let's get rid of that. Hit the up arrow, O tab. X squared plus 12x plus 10. I have no idea what this is going to look like. There it is. That's what it looks like. You know, if you want to really get a look at it, go zoom, window, and then try zoom fit, maybe. Maybe that'll help. Oh, that's kind of useless. Whatever. It doesn't matter, because what I want to do now is just tab and type in a new equation. My new equation is, of course, going to be parentheses x plus 6 squared minus 26. And hit enter. And notice it just wrapped right over it. It just printed right over it. And if it prints right over it, you got the right answer. So there she is, kids. So now I want to do the same thing with this one. Now this one's a little bit more complicated because of this 3. Now I can't get rid of the 3 like in completing a square. You just divide through and get rid of it. So what we got to do is take that 3 out. 3 x squared plus 18x plus 12. And then what we're going to do is use just this part to do completing a square on just this part right here. So we'll write x squared, and since I'm going to run out of room, plus 18x plus square equals negative 12 plus square. I already brought the 12 over because I know I'm going to do completing a square. So half of this is positive 9. So in here goes 81. So 81 goes over here. Wow, that's funky. Oh, no. I knew that was wrong. Hello, Mr. Krause. You're making dumb mistakes. You're making dumb mistakes. This should be 18, and this should not be 12. Let's go back. Let's find my mistake. I divided by 3, so this should be 6x plus 4. This is going to make a much better looking parabola. By the way, if I checked it on my calculator, I would have realized, duh, you made a dumb mistake. Hey, everybody makes mistakes. So this goes 6x here. And this was a negative 4. So half of this would be 3. 3 squared is 9, and add 9. So I end up with x plus 3 squared equals 5. Bring the 5 back, and I have my new equation, which goes over here. Oh, wait a second now. Hold on a second. I forgot. Man, see, this is what happens when you work at nighttime, making all kinds of dumb mistakes. So let's keep going. What we have here is x plus 3 squared minus 5. So this thing I'm highlighting is the same as this. But don't forget, you took out a GCF. So what we got to do is actually put that back in. We're going to wrap parentheses around this whole thing and put that 3 back in there. Well, what am I going to do with that 3? I'm going to distribute it. So that's 3 times x plus 3 squared. And then 3 times this is minus 15. So what's my vertex then? Well, my vertex is sitting right here, just like it was before. Negative 3 negative 15. Remember, when it comes out of the parentheses, it comes out backwards. And here. So I'm a little leery that I made a mistake. So I am going to come over here and check this. 3, 18, 12. So tab. Three, 18, 12. All right, so it kind of looks like that. Ah, well. And then I hit the down arrow, wherever that is. Tab. Go up here. And this was 3 in front. I'm really just trying to type this in, but of course I need a new computer. Everything freezes. Oh my God, escape. Okay, so boom, 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 boom. X plus 3. And at the end, it's minus 15. So hopefully it wraps right over that other one. Uh-oh. Oh, tab. I definitely have a dumb mistake. All right, kids, hopefully let's check. Hold on, am I recording? Yeah. So what happened was I just went back to find out where my mistake was. My original one I put in there is 3x squared plus 18x plus 112. I couldn't find out why I made a mistake. So I'm going to get rid of this and hit enter, and hopefully it goes right over that red one. Now it's hard to tell. So tab, hit the up arrow. We're going to get rid of the red one. Now it's blue. Now we're going to put the red one back in, and it goes right over it. See how it's going right over it? So I did get it right. But when I put it in here, this for some reason this was 112. Okay, that was driving me crazy because I wasn't sure what the heck I did wrong, and I knew I didn't make a mistake. So here we go. When I don't make a mistake, no, I'm just kidding. Let's go. But I am going to drink some coffee while I try to find my mouse pointer and not go back to day 7 notes. So kids, we are on completing the square. All I want to do is solve this equation by using the completing the square. So this is a little bit more complicated. Notice it says in simplest radical form. So we're going to have to probably do some simplifying when we're done. And I don't want a decimal answer. So I get x squared plus 8x plus square equals positive 2 plus square. Half squared is 16. And because it's positive 4. So what I get is x plus 4 squared equals 18. Now, I'm going to take the square root of both sides. And remember, when you take the square root, you put a freaking plus or minus. Now, square root of 18 is really 9 times 2, and that's 3 square roots of 2. So what I have here is x plus 4, because the square root and the square cancel each other out, is equal to plus or minus 3 square roots of 2. My final step is to squeeze that number right there in front. When it comes over, it becomes negative 4 plus or minus 3 square roots of 2. Ka-ching. This one says in a plus bi form, which means we're going to have an imaginary answer, which means we're going to have a negative under the radical. So x squared minus 6x plus square equals negative 21 plus square. Half squared is 9. So what I end up with is x minus 3 squared is equal to negative 12. Take my calculator out, take my thing out, take the square root of both sides, put a plus or minus. Let's take care of the square root of negative 12. That's negative 4 times 3. Well, what is the square root of negative 4? Notice I'm going to have I in my answer. What's the square root of negative 4? 2i square root of 3. So what I end up here with is x minus 3, because the square and square root cancel each other out, is equal to plus or minus 2i square roots of 3. And then I'm going to slide this forward. So I get 3 plus or minus 2I square roots of 3. So now we're going to do the same basic stuff on circles. What you do is you pull out the x's. X squared plus 8x plus square. Plus, now we're going to pull out the y's. Plus y squared minus 22y plus square equals, and we're going to bring this 13 over to the other side, but since I added 2 squares to the left, I got to add 2 squares to the right. So half squared is 16, so I'll put 16 there and 16 there. Half is negative 11. Oh, I should have put plus 4 in there. Negative 11 squared is 121. 121. So what I end up with this part is x plus 4 squared plus this part gives me y minus 11 squared equals, let's see, it's 29 and 21 is 150. So that's my equation. X plus 4 squared plus y minus 11 squared equals 150. What's my center? My center is negative 4, comma, positive 11. And my radius is the square root of 150, but I really shouldn't leave it like that. That's really the square root of 25 times 6, which is, of course, 5 square roots of 6. And that's my radius. There she is, kids. All right, here we go. So all I want to do is graph this thing on the axes over there. So first of all, I'm going to pull out the center. The center is 4, comma, 0. Remember, see, there's no number with the y, so the y part of the center is 0. And my radius is equal to the square root of 9, which is 3. So I go 4, 0, 1, 2, 3, 4. And I go up 3, right 3, down 3, left 3, and I draw in a sweet, beautiful looking circle. Center here is 0, negative 2. My radius is equal to the square root of 1, which is really just 1. So this one's going to be hard to draw. 0, negative 2. And I just go up 1, over 1, down 1, right 1. Little tiny circle. Now I want to work backwards. Remember, when the center goes in, it goes in with opposite points. So it's x minus 5 squared plus y plus 6 squared equals. Now over here goes the radius squared, and I don't want you to, I'm going to trick you. Be ready for it. If that's the diameter, then that means the radius is equal to 7. That means the radius squared is 49. So there's your equation. This one's a little bit more tricky. This is my center right here. So that gives me my first part. So that's going to be x minus 0 squared. Yes, I'm going to write that just for fun. Sorry, throat's bothering me. Molting over here. Y plus 1 squared equals, now I'm going to put the radius squared. Well, the radius is the distance between this point and this point, because this is a point that's on the circle and this is the center. So I got to find the distance between those 2 points. So I use my distance formula, and I get negative 4 minus 0 squared plus 2 minus negative 1 squared. Well, this is the square root of, this is 4 squared, so that's 16. And 2 plus 1 is 3, squared is 9. So this becomes the square root of 25, which is 5. Well, what goes here then? Oh yeah, 5 squared, 25. Beautiful. Oh, Chloe Wormsley says she can throw a lacrosse ball over 200 feet. Mr. Rybra has been measuring all of the metrics for the ball leaving her lax stick and has come up with the following function to model the behavior of the ball leaving her stick, where h of x represents the height of the ball in feet and x is the distance along the ball travels up the field. So what I want to do, okay, so let's answer these questions. What does the plus 8 represent at the end of this function in real life? Well, that's the Y-intercept. That's at time 0. Or actually, in this case, it's at horizontal feet 0, which means it just hasn't left her stick. But, you know, probably I shouldn't have used 8 feet with Chloe. Maybe I should have used like 6 feet. JKCW. Anyway, so this positive 8 represents the height of the ball as it's leaving her stick. And 8 foot's about right. They probably have about a 4-foot stick. She's probably about 4 feet tall, so that's like 8 feet. See what I'm saying? Just kidding. So anyway, so the positive 8 represents the ball height just before it leaves her lax stick. So how many linear feet along the ground will the ball be at its highest point? Now you got to think about this again, kids. All right, we only care about this first quadrant. It's going to leave at 8 feet in the air. It's going to go up some certain amount of height, and it's going to come down. And remember, this is the field. This is LeBeau Field. That's our turf. And it's going to go up. So I need to know how far up. Well, at the axis of symmetry, which is, that's not even close to being the middle, it will be at its highest point, and it will be midway through the distance along the field. So the first thing we got to do is find the axis of symmetry. So that's going to be negative b. So we're going to do x equals negative b, which is negative 3 over 2, all over 2a. 2 times negative 1/25. So I do that in a calculator. It's kind of complicated. You know how long it took me to come up with this equation? That was time consuming. So I'm going to do control division. You got to be careful with this one. Now, there's a fraction in the numerator, and there's a fraction in the denominator. So I want to make sure I do this correctly. So negative b is negative 5 over 2. Oh, negative 3 over 2. Sorry, forgot what I was doing. Negative 3 over 2. And on this one, it's 2 times negative 1 over 125. And I get whatever that is. So I type that up, hit that, get a decimal in there. Got to figure out what this is as a decimal. I mean, I could write 375 over 4, but 93.75 makes more sense. So 93.75 feet. Is that feet? Feet. At its halfway point. Now, it's not quite the halfway point, because remember, it started 8 feet in the air. So, what is the maximum height of the ball? So what I want to do with this is take this and put it into this equation. So I'm going to go back to my calculator. I'm going to go control division. Negative 1 over 125. Oh. What I'm going to do is control var x. So I stored 93.75 in for x. Now I'm going to do control division. Negative 1 over 125. Get out of that. The wrong button. X squared plus control division 3 over 2 x, and then we had a plus 8 at the end, I believe, right? Plus 8. So 78.3125 feet. 78.3125 feet. So her ball is going to go close to 80 feet in the air. And when it's at its maximum height, almost 94 feet away from her. So now what we're going to do is we're going to determine the appropriate window and scale that can be used on the calculator to graph this puppy. So as far as the x value goes right here, as far as the x max goes, halfway was 94. So double that, you get about 180, 190. So I'm going to go at least 200. I'm going to go a little bit more, maybe 210 or 220. And I want to do about 10% of this negatively, so I'll do negative 20. Just cross off this 0 at the end and pretend it doesn't exist. And like if I pretended this didn't exist, I'd get 21. So that's about how much negative you want to go. I just put negative 20. Really doesn't matter. And then the Y min, well, the Y max was 78, but that's cutting it too close. So let's go with 90. And then I would just do minus 9 here. Now I'm going to come back to this scale. Obviously this is 0, but I'm going to come back to my scale in a minute. I'm going to show you what the calculator kind of help you out with that. So we're going to go to our calculator. I think I got some other crap in there, so I want to delete that. I don't like having other people's stuff in there, so I'll go back in. And it's control division, negative 1 over 125 x squared plus 3 divided by 2. It'll fix it for me. X plus 8. It'll make it look pretty. Oh my goodness, there it is. But again, it's ugly, right? There's the equation. I told you to make it look pretty for me. So we're going to go in the window, and here, notice it's starting at 8, but no, it looks like a straight line. It doesn't even look like a parabola, but notice it's going to hit at 8, which is up here, the Y-intercept, and then it's going to go way up and way down. So what we got to do is change the window. So we go menu, window, window settings, and we said negative 20 here, didn't we? And we said 210. I didn't want to cut it too close. And besides, we're trying to see if she can throw 200 feet. We'll see. This was negative 9, I believe, and the maximum height was 78, so we went with 90. And I should get an automatic, I should get a pretty good, oh, perfect, right? I can see where it crosses the x-axis. I can see the maximum up here. There's plenty of room above. Maximum. I can barely see where it crosses. I can barely see where it crosses here. But notice it also gave me the scale along the x-axis. See how it says 10? So when I come over here, I'm saying, oh, I'm just going to use 10. It's a good scale. I like that. It gave it to me. Plus, you want to have about 20 data points. So if you divide this by 20, 210 by 20, you get 10. All right, so now we're going to graph it. I'm going to get some data points in there. So 0 and 0. I got to get to at least 200. So 20, 40, 60, 80, 100, maybe. 110, 120, 140, 160, 180, 200, 220, 240. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 120, 140, 160, 180, 200. I got to at least 200, so that's good. And I got to get to at least 100 this way, so let's go 10, 20. What you're trying not to do is to have some little big, huge graph paper and just draw some little thing like this. That's ridiculous. Nobody wants to see that. So this is 30, 40, 50, 60, 70, 80, and we went to 90. And don't forget, this is h of x. And this was x down here, which was the field. It's the field distance. All right, so let's see. At 0, I know it's 8. I also know at 94, it's 78. So I can do that now. It's about here. Let's see, that's 100. So 94, about there. I just don't know many other points. I'm not going to graph a lot. I want to graph this end point, or try to get close to this end point. So Control T. And, oh, look. This is silly. Look, am I going to really go through 200 of these? That doesn't make any sense, right? I don't want to do that. So what I want to do is go Menu, Table, Edit Table Settings, and I want to change this to 10 and change this to 0. So now it starts at 0. So 0 is 22, 10 is 22. I'm not going to do all of them. I might go 30 is 46, so 30 is 46. 50 is 63, so 30, 40, 50 is 63. 70, 80 is 77, so 80 is really close. So it looks like this is the first half of this. And let's go grab a few more. 130 is 68, so it's 20, 30 is 68. 180 is 20, so 180 is 20. I probably should have done a few more in between there. 150 is 53, so 10, 20, 40, 50 is 53. Now it's really kind of important what's happening around 200. So let's go see what happens here. So at 190, it's 4.2. So it doesn't look like she made it past 200. Looks like she's bragging a little bit too much. But there's a good title. Okay, that's it. Hopefully we only have one of those because those are a pain. All right. Oh my goodness. What problem are we on, by the way? Problem 10. Okay. So remember, we're going to try to create the equation. The equation is going to be y equals ax squared plus bx plus c. Do you see an x in this, or do you see an x in this? So we have to make up a point. X comma y. We're going to do easy. Easy is the distance between this y value and this line. Well, we just subtract the y's. Y minus 4. That's easy. Now we're going to do hard. Hard is the distance between the 2 points, between xy and 4, 6. So we're going to use the distance formula. X minus 4 squared plus y minus 6 squared. Now, according to the definition, these two distances, which is this and this distance, have to be equal to each other if, in fact, it is a parabola. That's the parabola. That's the focus director's definition of a parabola. So y minus 4 has to equal the square root of x minus 4 squared plus y minus 6 squared. So in order to get rid of the square root, I have to square both sides. And this square root cancel. Now this side, I'm not going to do this too often here, kids. This is y minus 4. So this becomes y squared minus 8y plus 16 is equal to, I'm going to double distribute this out, x squared minus 8x plus 16 plus y squared minus 12y plus 36. Now, if you don't know where I'm getting these, write these things out twice and double distribute. All right, so now I got to do a little work. These y squareds cancel. This 16 cancels when I move from one side to the other. So then I'm going to add 12y. So I get 4y equals x squared minus 8x plus 36. And my final step is just to get y all by itself. So I'm going to divide by 4. So my equation is y equals 1/4 x squared minus 2x plus 9. And there it is. All right, kids, I'm going to take a little break so I can get my computer back. And it's recording too much. It's a lot more than 22 minutes. 40 minutes already in. So we're going to stop, and I'll come back in a second. Bye. Well. I'm back. Okay, sorry. So what I did was I just ended that 40 minutes of recording so I can record another 40 minutes because this is a lot of fun. So we're going to do this again. Same problem. You probably won't see any difference, but I just stopped, recorded, did a bunch of work, and now I'm back. It seems like nothing happened, right? I know. That's the magic of video. Pretty good. All right, so again, we're going to pick a point, x, comma, y. We're going to do easy. Easy is the distance between the point and the directrix. In this case, it's d equals y minus 2. Hard, that's easy. Hard is the distance between the point and the... I'll bet it's... where is it? Oh, it's not updating the OneDrive. Well, it will in a minute. The distance between the point and the point. So we're going to go x minus -2 squared plus y minus 4 squared. And again, this distance has to equal this distance. So we'll write an equation. Y minus 2 has to equal the square root of x plus 2, because minus minus makes a plus, squared, plus y minus 4 squared. To get rid of the square root, I'm going to square both sides. That should be a parenthesis. Oh, parentheses. And square. So that square cancels with that square root. On this side, I get y squared minus 4y plus 4. Again, if you need to learn how to double distribute, just write it out. I'm going to double distribute this out, and I get x squared plus 4x plus 4 plus y squared minus 8y plus 16. So now all I got to do is solve for y. If you did it correctly, the y squareds cancel. In this case, I had these 4's cancel again. That's kind of nice. I'm going to add this 8y over. Why is it always 8y? That's weird. So I end up with 4y equals x squared plus 4x. This moved over. Plus 16. Divide by 4. I'll lose my voice. Divide by 4, divide by 4, divide by 4, divide by 4. And I get y equals 1/4 x squared plus x plus 4. I think I got 3 of these. So this one I decided to be a little bit trickier, and I didn't give you an equation for the directrix. Same problem. Got a point, got a directrix, but I didn't give you the equation. I just told you it was the x-axis. Well, you need to remember that's the line y equals 0. Now, if this is the case, and I give you this on a test, it's a much easier problem. We're going to do easy. Distance is equal to, oh yeah, we got to pick our point, x comma y. Y minus, remember it's point to line, so y minus 0, well that's just y. That's what makes it a little bit easier. And then hard, we got to find the distance between the 2 points. So it's going to be x minus 6 squared plus y minus 2 squared. The distance between these 2 points. Set them equal to each other, just as we've done before. Correct my toe. So I get y is equal to the square root of x minus 6 squared plus y minus 2 squared. To get rid of the square, to get rid of this square root, I'm going to square both sides. Well, you notice the left side's pretty easy. It's just y squared equals x squared x squared minus 12x plus 36 plus y squared minus 4y plus 4. Again, if we did this correctly, the y squareds are going to cancel. I'm going to bring this 4y over to this side, so I get 4y equals. Now I got to combine things. X squared is just by itself. X squared minus 12x. Well, this goes to the other side, so it's minus 12x. And 36 and 4 make 40, so plus 40. So my equation is y equals 1 over 4x squared. Because I'm dividing by 4, right? Divide by 4, divide by 4, divide by 4. Minus 3x plus 10. And there's my answer. Find the zeros of the following function. State the answers in simplest radical form. That is a huge indicator that it is not going to be factorable. It also says round to the nearest hundred. So we got to give our answers in two different ways. So I'm going to set this equal to 0. Negative 3x squared plus 10x minus 6 equals 0. Well, I can't factor this, and I can't use completing a square. So, and by the way, I don't like my a being negative, so I'm going to move everything to the other side. So 0 is equal to 3x squared minus 10x plus 6. So I'm going to use the quadratic formula. So a is 3, b is negative 10, c is 6, and d, you'll recall, is the discriminant b squared minus 4ac. Which is equal to 100 minus 4 times 3 times 6. And that is 12 times 6 is 72. So this is 28. Okay. So I'm ready to go. The formula is x equals negative b over 2a plus or minus the square root of the discriminant, which is b squared minus 4ac, all over 2a. Weird. So x is equal to negative b is positive 10 over 2 times 3 plus or minus the square root of 28, since I already did all that work, all over 2 times 3. Now I know I'm going to have to simplify the square root of 28, so I might as well do this off to the side here. That's 4 times 7, which is 2 radical 7. So I'm going to put that right here. 2 radical 7. So I'm really ready to roll now. So my answer is x equals, well, doesn't 2 go into 10 5 times? So this gives me 5 over 3 plus or minus this 2 cancels with this 2, the square root of 7 over 3. And there is my non-decimal answer. Now to get the decimal answer, I'm going to have to go over to my calculator and do 5 divided by 3 plus the square root of 7 divided by 3. Now don't worry, I didn't put it in there in the exact, oops, that's got to get out of there. Divided by 3. It's going to look pretty. It'll make it pretty. See, 5 plus. So it said round to the hundreds place, so 2.55. So 1 is 2.55. Now I'm going to grab my calculator. I won't have to retype that. I'll just hit the up arrow. Enter. And remember, it's plus or minus. I already did plus. All I got to do is the minus now. 0.78. 0.78. Those are my two answers. All right, moving on. Going to do the same thing here. Now, again, I'm just going to set this equal to 0. I can't, it's already positive, so I can't use completing the square. I have to use the quadratic formula. So A equals 5, B equals 6, C equals negative 3, D equals b squared, which is 36, minus 4 times a times c. So this is, I have no idea, 36, 4, 5, negative 3. 36 minus 4 times 6 times negative 3. $108. Ooh, that's a cool number. I like that number. You'll see why in a minute. So x equals negative b, negative 6, over 2 times 5, plus or minus the square root of 108 over 2 times 5. You know you're going to have to simplify the square root of 108. Now, if you don't notice the biggest perfect square that goes into it right away, but you do notice that 4 goes into it, you say, okay, 4 goes into it 27 times. Oh, wait a second. 27 has a perfect square. It's got a 9 that goes into that, so I can do this. Now, the biggest perfect square, obviously, is 36. That's 2, and that's 3. So it's 6 square roots of 3. So 6 square roots of 3. So we're almost ready to give our final answer. Do a little simplifying beforehand. 2 goes in here 3 times. So I get negative 3 over 5 plus or minus 2 goes into 6 3 times. 3 square roots of 3 over 5. There's my non-decimal answer. Grab the calculator. Negative 3 divided by 5 plus the, oops. Negative 3 divided by 5 plus 3 square roots of 3 divided by 5, I think. Yep, there it is. 4.4. 0.44. So one of my answers is 0.44. And my other answer will be, go up, enter, over. And I get negative 1.64. Negative 1.64. Find the equation of the form ax squared plus bx plus c that satisfies this equation. So what I decided to do is be a jerk, and all the examples are going to be like this. Page am I on? Okay, so my first point is 115. So the equations are y equals ax squared plus bx plus c. So in for a goes 15. In for y goes 15. And then a times 1 squared plus b times 1 plus c. Well, this equation is 15 a plus b plus c. Here's my first equation. My second equation is 31 goes in for y, and 3 goes in for x. So it's a times 3 squared plus b times 3 plus c. Well, this equation is 31 equals 9a plus 3b plus c. And my final equation is 6 equals a times negative 2 squared, be careful of negatives, b times negative 2 plus c. So this is 6 equals 4a minus 2b plus c. Now I can solve any one of these three for c, but this seems to be the least complicated. And I'm going to solve for c because it makes it much easier for me. So 15 minus a minus b is equal to c. All I did was move these two over. So wherever I see a C, I know it's equal to this. So I'm going to replace C's. There they are. I'm going to replace those two C's with this mess here. So let's do that. 31 equals 9a plus 3b plus 15 minus a minus b. Or, let's bring the 15 over. I get 16 equals, I subtracted the 15. 8a plus 2b. There's one of my equations. I'm going to bring this, so 6 equals 4a minus 2b plus 15 minus a minus c. I'm going to subtract this 15 over. I get negative 9 is equal to 3a. This should be c here. This should be b. Minus 3b. So there's my other equation. So I'm going to put those on top of each other. Negative 9 equals 3a minus 3b. Now there's no easy way to make to use elimination to get rid of one of these variables. So the easiest way is just to multiply this one by 3 and this one by 2. And you'll see why in a second. So my first equation becomes, well, I didn't give you a lot of room, 48 equals 24a plus 6b. My second equation becomes negative 18 equals 6a minus 6b. Well, if I add, I get 30 is equal to 30a, and these go away. So a is equal to 1. Well, I'm going to plug that back into, oh, this one looks a little bit easier. Oh, no, it doesn't. The first one does. I'm going to plug in that first one. So 16 is equal to 8 times 1, because a is 1, plus 2b. Subtract 8, and I get 8 is equal to 2b. Divide by 2, I get b equals 4. Almost done. I now have to find c. Well, if you remember correctly, this is c. C is equal to 15 minus a, well, a is 1, minus b, which is 4. So c appears to be 10. So I still have to answer the question. The answer to the question is y equals, a is 1, so it's just 1x squared plus 4b plus 10. Now, if I'm correct, I should be able to graph that and see these 3 points. So let's do that. So we're going to do x squared plus 4x plus, I don't know why I put b here, 4x plus 10. And this should be an x, not b. B is 4. And I want to see if I get these 3 points. 115, I think I'm, so it's, let's see, Control T. There's 115. There's negative 26, and the other one was 331. There they are in all their glory. We did it. Let's do it again. 1, 4. Plug in a 4 for y equals a times 1 squared plus b times 1 plus c, or 4 is equal to a plus b plus c. So I know that when I add a plus b plus c, it's going to add up to 4. That's my first equation. I'm going to solve it right for c right now. C is equal to 4 minus a minus b. So this one, negative 2 is equal to a times negative 1 squared plus b times negative 1 plus c. Or negative 2 is equal to a minus b plus c. And type in 13 for y, and in for x goes 2, so a times 2 squared plus b times 2 plus c. So this is 13 equals 4a plus 2b plus c. All right. So remember, we've got to get rid of one of the letters, and we're going to get rid of c, and we're going to type that in here, put it in for c. So what I get is, too much red, negative 2 equals a minus b plus 4 minus a minus b. Ooh, oh, this one's going to turn out to be nice. Negative 2, oops, hold on. I'm going to subtract that 4 and bring it over. Subtract this 4. So I get negative 6 is equal to, now notice what happens to the a's. This a cancels with this a. I already moved this 4 over, so I get negative 2b. So b is equal to 3. Oh, that's beautiful. I don't have to do any more work. If b is equal to 2 or 3, and I already know that negative, well, then what am I going to do? Oh, I got this other equation over here. 13 is equal to 4a plus 2b plus 4 minus a minus b. So 13 is equal to 4, no, that's not 14. I bring the 4 over, I get 9 is equal to 3a plus b. Well, b is 3, so this is 3. So I subtract 3, and I subtract 3, and I get 6 is equal to 3a. So a is equal to 2. Well, I'm almost done. I'm going to plug both of these back in over here, find c. So c is equal to 4 minus 2 minus 3. So c appears to be negative 1. So my equation is going to be y equals 2a squared plus 2x squared plus 3x minus 1. Go to my graphing calculator. Let's see if that's true. So 2x squared plus 3x squared plus 3x minus 1. So hopefully I see these 3 points in my table. Control T. Control T. And I need to see 213. There's 213. There's negative 1, negative 2. What was my other point? 1, 4. 1, 4. We did it. Yay, we did it. All right, we're almost done, kids. Oh, we're on the last page. Hey, we made it. All right, here we go. All right, so this page I didn't actually do very well, so I'm gonna change the problems up slightly, somewhat. So what I'm asking for here is, remember that f of x is the same as y. So what I'm saying here is, where are the y's less than 0? Or another way to say this is, where are the y's negative? I'm going to do that in color coded. Would you agree that down here the y's are negative, and down here the y's are negative? So, in this particular case where it says, hey kids, where is f of x negative? State the interval. State in interval, I should have put notation. I screwed up there. Interval notation. And graph it on the number line. So in interval notation, where this thing is negative is from negative infinity all the way up to negative 2. Now it doesn't include equal to, so this union, and starting at 6 and going off to positive infinity. Now, if I want to look at that graphically, it would be negative 2 here and 6 here. Open, shink, and open, shink. Almost done. This one says, where is it greater than 0? Well, it's greater than 0 when it's above the x-axis. Now, this is the problem. I'm going to do a different way. I'm going to do it this way, and then I'm going to erase it and do it in a different way. So from negative infinity to negative 2, but this time including negative 2 because it has the equal to, union starting at 7, including 7, all the way to positive infinity. And again, negative 2, close circle this way, 7, 7, close circle this way. That's the answer. Now, let's say I change up the problem because I should have written the problem differently. Let's say I said this, and I said, not this, greater than, less than 0. Let's say I asked for when it's less than 0. Well, less than 0, again, is negative, and that's all of this spot. So in between here and here, it's negative. So if I want to do that in interval notation, that would be negative 2, 7. Graphically, it would look like this. Negative 2, open circle, 7, open circle. And because it's in between, I connect the dots. I just didn't have a problem like that, so I want to show you, because the last one's kind of similar to the other two. All right, last problem. Where is it less than 0? Less than or equal to 0. Less than or equal to 0 is below here. I'll do this for problems twice too. So that will be from negative infinity to negative 1, but equal to, so equal to, union 7 to positive infinity. Or negative 1, close, going this way, 7, going that way. Now, that's that. And had I not put that on there and I just said, hey, where is it, let's say, greater than or equal to 0? Well, it's greater than 0 when it's above the x-axis, when it's positive. This is all greater than up here. So that would be in between here and here. So in this case, I would do bracket, negative 1, comma, 7, bracket. Or as far as the number line goes, negative 1, 7, close circle, close circle. And that, my friends, is the end of the practice test. I hope that you worked your butts off. I hope you're ready for the test. Good luck, kiddies.